Hi guys, in this video we'll talk about why you might want to use a correlation. What are some of the applications and what are some of the pros and cons? So why did we do a correlation? Well, the number one reason is that it probably will work best for the data that you have. Again, I feel like I'm saying this over and over again, but if both of your variables are continuous variables, then a correlation will just work better from the data that you have. The other applications for correlational design that your textbook talks about are that it allows us to evaluate a theory, test predictions, and to establish measurement validity and reliability. Whoa, that takes you back from before the midterm. Do you remember when we learned about this way back in lecture 2? Well, to do this, we need to run correlations. So let's unpack all of these different applications now. So correlations can be really beneficial because they can add support for a theory that was based on an experiment or non-experiment or quasi-experimental research strategies. So remember, one of the goals of science in general is for a study to be done and then for future studies to build on what was done. So if one study finds that there's a relationship between two variables because they've compared two groups of people on that dependent variable, if we do a correlation design and we try to see whether there's a relationship between those two variables, but instead of comparing groups, we're looking, measuring that variable in a more continuous way. And if we find that we also see a relationship using a correlational design, well, this adds support to the results that were found in that other study. So this is all very hypothetical. Let me give you an example, and hopefully my computer won't reboot as I'm doing this. Okay, so imagine you're interested in whether people who have difficulties with attention, whether this impacts their academic performance. So our research question is whether difficulties with attention or inattention affects academic performance. So maybe we could do a non-experiment or a quasi-experiment where we compare kids that have a diagnosis of ADHD compared to kids that don't have a diagnosis and look to see whether there's a difference in their academic abilities. Or maybe we find that there is, maybe we'll show that there's a group difference. Well, ADHD and a lot of other neurodevelopmental disorders, we're starting to understand that probably is not a categorical thing, that you either have something or you don't. Autism, we understand that as being more as being on a spectrum. ADHD is probably on a spectrum too. And there's probably lots of kids in the classroom that even though they don't have a formal diagnosis, still struggle with attention and display a lot of the same ADHD traits. So we can ask the same question rather than comparing a group of kids with a diagnosis versus kids that don't have a diagnosis. We can measure their attention, we could measure their ADHD tendencies or traits as a continuous variable, and we can look at their academic performance, which is obviously also on a continuous variable, and look to see whether there's a correlation. If we find that there is a correlation, then this would add support to those other studies that were done that found a group difference. So the data from those previous studies might be showing that, let's say this is our group with ADHD, this is our group without ADHD. We can look for that same relationship using a correlational study. And those kids with ADHD will probably fall on this far end of the spectrum. But the point is that we could probably also find the relationship even among kids that don't have this diagnosis. So if we do, it just adds support and allows us to evaluate that theory even better. Another great application of correlational research is it allows us to make a prediction. So once we demonstrate that there's a correlation, a relationship between two variables, in the future, we only need to measure one of those variables to make a prediction about what the person's score on the other variable might be. So this allows us to use past behavior to predict future behavior or behavior in future participants. So for example, if we found, like we talked about in the last video, that a correlation exists between the number of hours you spent studying and your exam scores, then we can predict in the future those who study more will probably have higher exam scores than those who study less. And in 3P15, you'll be learning about regression, which is makes use of these correlational strategies in a slightly different way in order for us to really make those predictions, and it creates an equation that describes the relationship between multiple variables, allowing us to determine whether scores in one variable can be predicted from scores in another variable. So stay tuned, you'll learn more about that next year. So here's a good question to check your understanding. Imagine there's a negative relationship between the number of hours that kids spent playing video games and their grades in school. What grades would you predict for boys who spend more than the average amount of time playing video games? Why don't you pause the video and see if you can answer this question? Well, it's probably no surprise, this prediction, using what you found in this correlation that happened in the past, you can predict that they'll probably have lower than average grades. So the third application for correlational research strategies is that correlations allow us to establish reliability and measurement validity, which we talked about way back in lecture 2. So if you recall, reliability is all about how consistent or stable a measurement procedure is. This is a lot like what we've been talking about with correlations. Measurement validity evaluates the extent to which a measurement procedure actually measures what it claims to be measuring. And one way we can determine that is by seeing whether scores in one measurement test relate to scores on another test. So both reliability and validity are often established using correlations. This is a great chance for you to review and see if, check your understanding of some of that content from lecture 2. This will be covered in the exam. See if you can answer what are the 3 measures of reliability and what are the 6 types of measurement validity. I'll give you some of the answer here to illustrate how we can use correlations to determine them. So reliability, again, measures the consistency or stability of a measurement. We talked about 3 ways that we can establish reliability. We can have 2 researchers observe some behavior and look to see how consistent our 2 observers are in rating that behavior. This is called inter-rater reliability. So if we show a strong positive correlation, it would mean that rater 1's scores for participants are very similar than rater 2's scores for participants. Test-retest reliability measures the extent to which a person's performance on a test given on a Monday is going to be similar to their performance on a test given on a Friday. If we show that performance is similar, we would be looking for a strong positive correlation between those 2 test scores taken at different times. And then finally, if we wanted to see how reliable our test was, we could look to see how people's performance are, let's say on odd numbered questions and even numbered questions, and look to see if there's a correlation between those scores. So all of these could only be possible with a correlational research strategy. Similarly, to determine measurement validity, one way that we could do that is by looking at convergent validity, which is checking whether if 2 tests are really measuring the same construct, we'd be looking to see that they would show a strong correlation with each other. Similarly, if 2 tests are measuring very different constructs, so for example, a test of anxiety and a test of how long you can do this for, I think that was the example I gave way back when, they're probably measuring very different constructs. They should show no correlation with each other. So what are the pros and cons of correlational research? Well, the pros are that they allow us to describe the relationship between 2 variables that naturally exist in the world and that vary among participants and among people. So correlational research tends to give us very high external validity. On the other hand, the internal validity is rather low because we can't ever be sure 100% that the relationship that we are seeing is you know, if that one variable is causing the change in the other variable. So as a result, we tend to have low internal validity. And correlation designs suffer from the same challenges that non-experimental and quasi-experimental designs do, that we can never rule out the 3rd variable problem and the directionality problem. So to illustrate that, let's say we wanted to see if there's a relationship between how active somebody is and how depressed they feel. We may find that there is a correlation. We would probably find that it's a negative correlation, so the scatter plot's probably not that accurate. Probably we would find that the more more exercise we get, the lower the depression scores. So we may find that there is a correlation, but we can never be sure that it's the activity that's causing the depression scores to change. There could be some third variable that's explaining that relationship. So for example, people who have less stress at work maybe have more time to have lots of exercise, and it's the stress at work that's really explaining that, the change in the depression scores. So just like for non-experiments, we can't rule out the third variable problem with correlations. We also can't rule out the directionality problem. We can't be sure if there is a relationship between how active somebody is and their depression scores. We don't know if higher activity is causing somebody to have lower depression, or if it's the other way around, that people who are more depressed tend to have less activity. So we don't know what's the chicken or the egg. Only experiments where we manipulate one of our variables and control external variables can we rule out the directionality problem and the third variable problem. So a correlational study, just like a non-experiment and quasi-experiment, does not allow us to establish cause and effect relationship. Correlation does not equal causation. And to review some of this, you can go back and rewatch some of the video that Jonah created. He really explained that in a great way. So if you take anything out of this course, in the future, when you are reading about studies in the news or reading a study, primary source article, or if you're a teacher and your principal is suggesting that you adopt a new program, really think about what is the data that led those people to draw their conclusions. If they base their conclusions on a correlational study or a non-experimental study where they haven't manipulated the variable and they have the independent variable and they haven't controlled for external variables, we really can never establish causation. So be very skeptical when somebody thinks that one variable is going to cause change in another variable if the design is a correlational design. Here's a great review activity for you to see if some of these concepts are true. Here are some variables that might differentiate university students up here. Pick 2 of them that you think might show a strong positive correlation and 2 that you might think might show a strong negative correlation. How would you do a correlational study to evaluate this relationship? And how could the same relationship be examined using a non-experimental or a differential groups research study? And we'll talk about your ideas at our next Teams meeting. So to summarize, correlational research is really useful. It can allow us to make predictions about the relationship between variables in the future using what we've found in the past. We can establish measurement reliability and validity, and importantly, we can evaluate theories that have been developed using other research designs. Correlations tend to have high external validity, but tend to have low internal validity because we can't rule out the third variable and directionality problem. So we can describe a relationship between 2 variables, but we can't say what the cause of that relationship is. Thanks so much for listening, and we'll see you at our next meeting. Have a good night.